In this demo, I'm going to show you how to start using volumes. I'm going to use my kops cluster again. So I logged in again in my Vagrant Xenial box. And first, you will need to create a volume on AWS. And if you're working with kops, then you must have set up the AWS tool, because that was one of the prerequisites. So I'm going to use the AWS tool to create a volume. I'm going to use AWS EC2 create volume. I'm going to create a volume of size 10 in EUS 1A, and it's going to be general purpose 2, which is just an SSD volume. Make sure that you create your volume in the same zone that your Kubernetes cluster is spun up, otherwise it's not going to work. This is the volume ID that you need to select. You need to copy paste this, and then I'm going to insert this into my hello world with a volume. So I'm going to use this volume ID. I'm going to put it right here, volume ID, and then this volume ID. And this volume ID is going to be attached to the node that this pod is going to run on. And it's going to be mounted under /myvol. Let me first check whether my nodes are running. I have 3 nodes running. And then I'm going to launch this deployment. Hello world deployment created. kubectl get pod. Container is creating. It's pulling the image. And now the container is created. We have a volume here, my volume, which is a persistent disk resource in AWS Elastic Block Storage with a volume ID. So I should now be able to execute something in this pod. Let me just start bash, and I should have a volume myvol. Let me just write something in this myvol just to see how it works. I'm going to write test in myvol.txt. I'm also going to write text in test2 in /test.txt. So we have 2 files, myvol.txt and test.txt. And just think about what is going to happen if this pod crashes, because we wrote something in / and we wrote something in the volume. When does a pod go? Well, if the node goes, then the pod needs to be rescheduled. So this pod is running on the node with this IP address. So if you want to test what would happen if the node would be rescheduled, we could drain a node, which means we prepare the node to go offline. So we can say kubectl drain and then the node, and then it's going to start draining the node. I'm just going to use force here. So that pod is for sure killed. Then I'm going to do kubectl get pod, and already a new pod is being created. So if I describe this one, describe pod, and then the new pod, then you can see that this pod is now attached to another instance. You just have to wait a little bit until the warnings go away. And now the volume is attached to this new node. So what happened is that this volume detached from the old node and now is reattached to the new node. So our container has been recreated, but we are still using the same volume. So let me log in again. Let me open a shell on our new pod. And if I take a look in myvol, I will see that I still have myvol.txt, but of course, because this is a new container, I don't have test.txt anymore, because test.txt was not saved in the volume, but in the container itself. And when the pod gets rescheduled, all the information that has been written to the container disappears. So when you have a stateful application that needs to write something, then you always need to use volumes, because then your data will be kept even if the node crashes or even if the node needs to be rescheduled. And this can happen all the time. Stateful applications you can only use with volumes or some other mechanism to save the data, not inside the container itself, but using a volume or using external services. In the next lectures, I will show you how Kubernetes can automatically create those volumes for you. When you're finished, make sure that you remove this volume again. So this volume needs to be deleted. AWS EC2 delete volume with volume ID and then the volume ID. Of course, when it's not attached anymore. So you can only do that when it's detached. So first you need to remove your pod, and then if you wait some time, you'll be able to detach it.